Besides magic.
Arctan, right?
Arctan, all right. So theta would be the arctan of the opposite over the adjacent. Which is something bigger than 45 degrees. I'll go out on the limb on that one. Let's go with 51.7.
Yeah, 55.
55?
0.00.
Yeah.
Is this correct?
Correct.
People are feeling confident. Thank you. If we didn't put degrees there, what is implied? All right. So we now have an angle. Now what? Oh, this one over here? Oh, this one up here?
Yeah.
Okay, so if that's 55, I'm gonna go out on the limb again, and let's say 35 degrees. Randomly picking a number. This isn't right, angle. We assume Euclidean space. No curvature of space here. All right, so I have this, so I now have this vector here, angle of 35 degrees. This is our EP minus.
So we plug in.
Wait, hold on just a second. But we don't know enough, we can't make any conclusion about the relationship between those three other than they add up to 180. All right, so ultimately we're adding vectors here. Are we gonna use law of sines, law of cosines, or are we gonna put it in rectangular form? Yeah, that sounds like a nicer one, especially since math 172 is not required for this course. So rectangular form. I have an angle, I have an arrow. How do you put a vector into rectangular form?
Wouldn't that be?
Okay, we have I hat, J hat defined.
And we use that angle, and we plug it into do we use the 8.99 times or no?
How do you want to use that?
We can use. Can we use 2 and or we use -2 for that one, right? -2, yeah.
Nanocoulombs.
Yeah. Or no?
Okay, how are we going to use this? Yes, we will use K and we'll use that. The question is, how do we do it? Or why?
Well, you need to know the magnitude of the vector.
Yes. In order to break a vector up, we do need to know more than just the angle. We need to know the magnitude, which comes to the formula, which comes into those things that Jabez was just saying. The magnitude of EP negative just give me Q over R squared. So we have, you want to use, Jabez, you said 8.99, or do you want to use 9?
8.99.
8.99, all right, so 8.99 times 10 to the 9th. Newton meter squared for Coulomb squared. Times the charge, the magnitude of the charge, so that's 2 times 10 to the negative 9th coulombs, divided by the distance squared. And what is that distance? Pardon?
30.3.
No, It would be, it's looking at the distance from this charge to point P, not between the charges, but this distance here. This
You have to
distance
use
here.
Pythagorean theorem. to figure
That
it
sounds like a splendid idea. So. Four, so, 0.12. 122.
out.
0.122 meters squared. So 18 divided by 64, so 18 divided by 18, so. Oh, wait, no. Four, so it's- Somewhere around 900.
You got 1,208. Point 001 or 009.
So what you said, all right, groundswell of 2. All right, we're up to 3 now.
Nanocoulombs? Or no,
Yeah.
Newton coulombs.
Yes.
What'd you say again?
For the unit, Newton coulombs?
Newton's coulombs? No.
Yeah.
Carly, did you say something else? You just said Newtons? No, can't, what, Newtons would be force, and this is not quite force.
What's that to the right? Oh.
And it was close.
I see.
Mm.
Newton's over.
Yes. Newtons per coulomb. There is no nice single unit expression for electric field. For whatever reason, they decided Newtons per coulomb is good enough. So we now have the magnitude 1,208. I'm just gonna round off Newtons per coulomb at this 35-degree angle from the vertical. We now need to figure out how far down and how far over. This is the adjacent to the 35, so this is 1208 cosine of 35 degrees, or you could have done sine of 55. And 1208 times the sine of 35 degrees, or cosine of 55 degrees. So therefore, how far down, how far over? That's roughly a half, so around 600, a little bit more than 604, so let's go with 621.7. And this one is roughly 0.86 times that. So let's go with 9. So let's somewhere around 1,000. Let's just randomly go slightly below. So 972.6.
692.9.
690. I assume this one. 692.9.
Yeah. And 989.54.
989.51.
54.
54.
And
Sorry,
then
I was
nano over, or nano over two. We're not,
Yeah,
Newton.
all right. So therefore, we now have EP negative in polar form is 692.9 newtons per coulomb I hat minus 989.54 newtons per coulomb J hat. We are halfway through the problem. We're gonna do something very similar to the EP positive. So questions on this before we, I guess I don't have to erase it, I can just use the space over here. Maintain the tradition of getting farther from Denise. Any questions? I was about to ask, at what point is it really kind of difficult for you to see the board? I'm guessing we're at that edge.
No, just like when you like get to like the far side.
Over
Yeah,
here.
like when you're like all the way down there, it's like,
All right,
Go right
how
down.
far over should I go? Tell me,
oh, about right there.
right there? All right.
Yeah.
Any questions? All right, so the other one. Let's say we started out trying to find an angle here, so let's do something similar. So I've got this positive charge here. This was 0.1 going up, and this is 2 point, not 2 points, I only expanded it, 0.23 meters, 0.1 meters. What is that angle? There's our physical triangle. It is similar to the electric field triangle.
The arctan
I'll call this angle phi. So phi is the arctan.
0.1 over 22.
I got 23.5
You said 23.5?
degrees. That's rounded.
That's what I remember.
All right. The next thing we did was try to figure out the magnitude here. Because ultimately, our electric field is going in that direction. Let's trace up a marker. Our electric field's going in that direction at this angle of 23.5 degrees. So we need to figure out how big is, what's the magnitude of the triangle, of the electric field. And well, we have a formula right there. But we need to know this distance. The distance between our charge and the point, and point B.
.251 meters.
0.251.
Yeah.
So plug it in. So electric P positive, magnitude 8.99 times 10 to the 9 times 2 times 10 to the negative 9 divided by 0.251 squared. So it's more around 72, be just shy of 72, so how about 74? I think I'm off a decimal there. So that was a value.
I'll try, you gotta find your calculator.
Yeah, I did.
Oh, who's my problem? Four, so.
Got 285.
80?
285.4.
Oh goodness. Oh, you divide. Okay. What did you get for the About 70.
It's over.
Did you do the negative 9?
Oh, negative 9.
There you go.
All right. First time I forgot to square it, that was my issue. All right, so 285.4. Draw the triangle over here. So I have this 285.4 newtons per coulomb, and this angle is 35, wrong problem, 23.5 degrees. How far over, how far up? This would be therefore 285.4 cosine of 23.5 degrees, and 285.4 sine of 23.5 degrees. So 251.68 and 130. Yeah, 97.19.
261.73 and 113.88.
What, 13.8? So, we went to the right, 261.73 newtons per coulomb I had, plus, since we went up, 113.8 newtons per coulomb J hat. And now the final answer. We're asking for what is the total electric field at that point, so we just add. Doing the fancy math here, so not all of them significant, but what the heck? 3, 6, carry the 1, 4, 5, carry the 1, 954.63 newtons per coulomb I hat, plus, minus 4, 7, 5, 7, 8. I'm not opposed to making Carol some error just then.
Negative 989.5 plus 113.8, I got negative 875.7.
Oh, that's a 5-4 there, so I have
Oh,
the 4.
5, 4, okay.
Okay, all right. And you got the same as the first thing I got?
Yeah.
Okay. Yeah, well, if you would drop that 4 on a quiz or test, I would take off of that. I mean, they're clearly, we took significant figures into account since the second one goes out to a 10th place, then we will only go out to the 10th place here from a significant figure point of view. Flashback to the first lab last semester for most of you. Good times.
Very.
That's fun.
Yeah, and Devin and Julissa on the video, I don't care about significant figures.
Okay.
I didn't know if it had been ingrained in you at this point. If you want to go with significant figures on labs, tests, quizzes, and so forth, go for it, but I don't care.
Release some stress.
Was that?
Release some stress.
Okay, good. That's what physics is all about, relieving stress. All right. Any questions on this? And don't worry, you'll have an opportunity to do this on your own. All right, I'm gonna do a similar problem to what we have right here. I'm gonna change it slightly, so let me erase most of it. I guess we still need a point system.
So we just found the entire electric field for that or that
We
couple.
found the amount of charge on it from each of the particles.
Oh, okay. Cool. Thank you.
At this point right here, I have a charge equal to .1 microcoulomb.
What are these problems called?
What are the problems called?
Yeah,
The electric field problems?
okay.
What is the force on charge Q?
What's the
Now, if we had done this, if I had started out with this problem, what's the force on it? This would have been a problem very similar to what we did yesterday. Or last time. Monday? Monday.
Wednesday.
Wednesday, thank you. One of those days of the week. But we've done almost all of the work. Now, we solved for the electric field, we didn't solve for the force, but what's the relationship between them? Recall that when we found the electric field, all we did was take the force and we divided out a charge. So the force acting on